Hi guys! We're group number 14 and today we're going to talk to you about managing projects.
For my part, I'm going to help you have a better understanding about the objective of project management and why it is so essential in developing information system. First, let's take a look at the definition of the project management by watching a video.
Everywhere you look, projects are underway. Whether you're recruiting a new member of staff or constructing the world's tallest building, every project needs a manager to ensure its success. Someone with their eye on every detail, at every stage, from inception to completion. Put simply, project management is about getting things done. It's about knowing exactly what you want to achieve, how you're going to achieve it, and how long it will take. It's about ensuring that everyone involved shares and understands those aims before the first steps are taken, and that they continue to as the end of the project, whatever it is, draws closer. Because successful projects don't just happen. They're not just a long list of jobs to be done. They're a masterpiece of planning, management, organization and communication, a carefully choreographed sequence of events where progress is smooth and steady. One step leads seamlessly to the next, and every possible hitch has been considered and counted. A successful project needs people with the right skills and knowledge at its heart. Working together, a well-managed, motivated team with clear roles, responsibilities and reporting lines will carry a project to its conclusion without compromising on time, cost or quality. Project management is a wonderful thing, but it's easy to forget how the world might look without it. Because, at its best, project management is virtually invisible. It's the absence of problems and the prevention of failure. But behind every successful project, whether it's changing the way a company works or the organization of an important event, there's an unsung hero, the project manager, who kept everything and everyone on track to ensure the delivery of the desired result.
So, in short, project management refers to application of knowledge, skill, tool, and technique to achieve specific targets within specific budgets and time constraints. Project management activities include planning the work, assessing the risk, estimate and acquiring resources required to accomplish the work, organizing the work, directing execution, and analyzing the results. When an information system fails to work properly or costs too much to develop, companies may not realize any benefit from their information system investment, and the system may not be able to solve the problem for which it was intended. You can see the list of possible consequences of mismanagement system development projects in the slide. In conclusion, good project management is essential for ensuring that systems are developed on time, on budget, and provide genuine business benefits. Project management must deal with five major variables. First is scope. Define what's work or is not work included in a project. Second is time. The amount of time required to complete the project. And third, cost. Based on the time to complete a project multiplied by the cost of human resources required to complete the project. Fourth, the quality. An indicator of how well the end result of a project satisfies the objectives specified by management. And finally, is the risk. Refers to potential problems that would threaten successful of the project. To provide you more information about project management, my friend will continue about selecting projects.
Okay, so let's move on to our next part. It is about selecting project. As you may know, the first need to select a non-project, the one that promises the greatest benefits to the business. The figure here shows the elements of of management structure for information system project is a large corporation. It has ensured that the most important projects are given priority. As you can see at the apex of the structure is the corporate strategic planning group, which is responsible for developing the firm's strategic plan. This group will often have developed project objective measures of firm performance, core key performance indicator, and to support IT projects we can make a substantial improvement in one or several key performance indicators. The Information System Steering Committee here is the Senior Management Group. With responsibility for system development and operation. The steering committee reviews and approves plans for the system in all divisions, seeks to coordinate and integrate system, and occasionally becomes involved in selecting specific information system projects. This group also had a keen awareness of the key performance indicator decided on by higher level managers and the board of directors. The project team. The project team is supervised by a project management group composed of information system manager and end user managers responsible for overseeing several specific information system projects. The project team is directly responsible for the individual system project. It consists of system analysts, specialists from the relevant end user business area, application programmers, and the hard database specialists. Let's move on to the next part about linking system. Linking system project to the business plan. To identify the information system project that will deliver the most business value, organizations need to develop an information system plan that supports the overall business plan. Uh, the plan indicates the key management decisions concerning hardware acquisition, telecommunication, centralization, decentralization, authority, data hardware, and organization change, including management and employee training requirements, recruiting efforts, change in business processes, authority, structure, or management practice. To develop an effective information system plan, the organization must have a clear understanding of both its long and short-term information requirements. An organization's information requirements are determined by a small number of key performance indicators, or KPI. KPI are shaped by the industry, the firm, the managers, and the broader environment. For instance, KPI for an automobile firm might be unit production cost, labor cost, factory productivity, rework and error rate, customer brand recognition surveys of manager. Okay, about the portfolio analysis, it's the firm is used to evaluate alternative system projects is inventory all of the organization information system project and set and each information system project had its own set of risks and benefits, and firms could try to improve return on portfolio, balance risk and return from system investment. Besides scoring models, is useful for selecting projects where many criteria must be considered. It assigns weight to various features of a system and then calculates the weighted total. Using this table here, the firms must decide two alternative enterprise research table here so that this particular company attacks the most important two capabilities for sale, order of processing, inventory management, and warehousing. The second column is in the table list the weight that that decision makers attach to the decision criteria. Column 3 and 5 show the percentage of requirement for each function that each alternative ERP system can provide. Each vendor score can be calculated by multiplying the percentage of requirement met for each function by the weight attached to that function. As you can see, the ERP system B has the highest total score. So that's the end of my part. Uh, Now let's move on to the next part, which is presented by my friend. Hello everybody, my name is Huyền and I'm going to tell you about my part, which is establishing the business value of information systems. The first value is cost and benefit. The cost includes the cost of hardware, telecommunications, software, and services. The tangible benefits can be qualified and assigned a monetary value, and the intangible benefits are more efficient customer service or enhanced decision making. Secondly, the capital budgeting, which consists of the payback method, the accounting rate of return on investment, or in short, ROI, and the net present value. The final part is the internal rate of return. The payback method measures the amount of time required to pay back the initial investment of a project. It is calculated by dividing the amount of the original investment, and the ROI calculates the rate of return from an investment by adjusting cash inflows produced by the investment for depreciation. The net present value is the amount of money in an investment is worth, taking into account its cost, earnings, and the time value of money. The final part, internal rate of return. The final part, internal rate of return, is the rate of return of profits that an investment is expected to return, taking into account the time value of money, and the IRR is the discount or the interest rate that will equate the present value of the project, future cash flow due to the initial cost of the project. The real options pricing models, or in short ROMs, can be used when future revenue streams of IT projects are uncertain and upfront costs are high. The ROMs use concept of options valuation borrowed from financial industry and gives managers flexibility to stage IT investment to gain more knowledge about risk before investing in entire implementation. So now I will move to the first part, which is managing project risk, presented by my friend. Okay, hi guys, my name is Lee and now I'm gonna talk about the managing project risk. Okay, let's take a look at the dimensions of project risk. There are three elements that directly influence the level of project risk. It is the project size, project structure, and the experience with technology of project staff. The statistics show that the very large scale system projects have the failure percent of 50 to 75% higher than that for other projects because such projects is complex and difficult to control. And also the projects that have the higher structure than the other have the lower level of project risk, and the experience of the technical staff is important too. The project risks rise if the project team and the information system staff lack the required technical expertise. Okay, um, as you can see, many information system projects stumble because the project of organizational change surrounding building system was not properly addressed. Successful system building requires the careful change management, and to do that successfully, we need to apply the process of implementation. So what's the change management and what's the implementation? The change in how information is used often leads to new distribution of authority and power is the change management. And the implementation refers to all the organizational change activity working towards the adoption, management, and routinization of an innovation. And in the implementation process, the system analyst is called the change agent. His or her duty is to develop the technical solution and also redefine the configuration, interaction, job activities, and power relationships of various organizational groups. And that's also the catalyst for the whole process, responsible for ensuring that all people involved to that uh, accept the change of new systems. Also, the relationship between user and information systems specialists has traditionally been the problem area for information system implementation efforts. User and information system specialists tend to have different background, interests, and priorities, and that leads to the loyalties, priorities, and vocabularies, and also the gap between communication is also the problem between user and designer, and is the major reason why users are driven out of the implementation process. The management support and commitment is have many uh, positive effects. Like, first of all, it is that if an information system project has a backing and commitment of management at various levels, it's more likely to perceive positively by both user and technical information service staff. Both of them will think that their participation in development process will receive higher level of attention and priority. Second is management backing also ensures that a system project receives sufficient funding and resources to be successful. Also, to be enforced effectively, all the change in work habit and procedure and any organizational realignment associated with new systems depend on management backing. So it helps enforce required organizational change. Okay, so I'll talk about the risk factor and how to control it. My friend Ling here is gonna talk about you in the three parts.
Hello, my name is Ling and I will continue with part 3, controlling risk factor. In my part, there will be 3 small sections: managing technical complexity, formal planning and control tools, increasing user involvement and overcoming user resistance. Now let's start with section 1, managing technical complexity. First, technical complexity can be managed by internal integration tools. Internal integration tools are project management techniques that ensure the implementation teamwork as a cohesive unit. Second, project leaders need both technical and administrative experience. The team members are also have to be highly experienced. In section 2, formal planning and control tools, I want to introduce you two most commonly used methods for documenting project plans. They are train track and PERT track. A chain chart is a type of bar chart. It illustrates the start and finish dates of the terminal elements and summary elements of the project. However, it does not describe text dependencies. Text dependencies tell you how one text is affected if another is behind schedule or how text should be ordered. And another one is PERT chart. PERT stands for Program Evaluation Review Technique. It graphically describes project tasks and their interrelationship. The PERT chart lists the specific activities that make up a project and which one must be completed before another one can start. As you can see in the slide, here is an example of PERT chart. Now let's move on to section 3, increasing user involvement and overcoming user resistance. As you can see here, I want to mention about external integration tools. It is a project management technique that links the work of the implementation team to that of users at all organizational levels. I also want to introduce you some strategies to overcome user resistance. Here are 4 strategies. First, user participation. Second, user education and training. Third, management ethics and policies. And the fourth, better incentives for cooperative users. Now let's move on to part 4, designing for the organizational. We all know that the purpose of new system is improving the performance of organization. So areas where users interface with the system require special attention with sensitivity to ergonomics issue. Ergonomic issue here refers to the interaction of people and machines in the work environment. In this part, I also want to talk a little bit about organizational impact analysis and socio-technical design. Organizational impact analysis explains how upcoming systems will affect the organization, such as organizational structure, attitudes, decision making, and so on. Socio-technical design is a method to address human and organizational issues into information system projects. And here I have a short video that could give you some background knowledge about socio-technical systems.
Socio-technical systems is a relatively new area which takes a more holistic approach to the development of engineering projects that involve the interaction between people and technology. But let's start by taking an example of how our traditional approach to the development of technology and social organization works. Take Bob and Alice. They're both web developers and they both work on the same website. But Bob is a back-end web developer. He eats databases for breakfast and spends his days crunching code. Whilst Alice is a front-end web designer, she makes words sing and graphics come alive in simple and user-friendly interfaces that people love. Every few months the site needs updating and Bob works hard behind the scenes coding away. He then hands the project over for Alice to work her magic on. This works fine initially, but as the site grows with more employees being taken on, things become a little less straightforward. We soon have multiple people working on increasingly specialized areas of the site, with developers and designers often needing to interact and collaborate but finding themselves stuck in their separate departments. Bob and Alice's site now requires a more holistic and non-linear approach to overcome this stumbling block, as it has now become what we would call a complex socio-technical system. But what does this mean exactly? Firstly, it is complex in that it has multiple elements such as lines of code, databases, graphics, and so on, with all of these different things needing to interact and being dependent on each other's functioning. Secondly, it is socio-technical, as a website represents an interface between the technical domains of computer software and the human interaction. For the site to function fully, we need to design both areas to work together. When we look around us, we can begin to see socio-technical systems everywhere. Let's take another example. This is a subway station in Hong Kong. It represents a highly integrated set of diverse elements. From the residential area to the commuter center to the transport hub, it was engineered and constructed by a single company. The designers of this system needed to think not only about how the physical technologies would interact and work together within a confined space, but also about how the residents and commuters might wish to use the system for multiple different functions. The website and subway stations are examples of systems on the small to medium scale. As we enter the 21st century, many of the challenges we face involve macro-scale socio-technical systems, such as growing demographics and urbanization, with urban infrastructure companies now offering solutions that integrate power grids, water supply, transportation, and other utilities that must interface with thousands of people on a daily basis and have a strong influence on the social fabric. Or with respect to the environment, where nations must balance both social needs, technological requirements, and environmental considerations to manage and grow efficient and sustainable economies. So we can think about socio-technical systems then as an approach to overcoming the problems of optimizing either the social or technical side to a project in isolation, and a more holistic method for developing synergistic relations between both areas that create optimal solutions for the system as a whole.
Okay, and now is the final part of our presentation. Project management software tools. First, we should have some knowledge about project management software. It has the capacity to have plan, organize, and manage resource tools and develop resource estimates. While project management software help to track individual projects, the resources allocated to them and their cost, the project portfolio management software can manage portfolios and projects and dependencies among them. There are four types of project management software: desktop, client server, web-based, and integrated. And here I have some example of management project applications. As you can see, there is Microsoft Project, Maxwell MindView, Project Kickstart, Basecamp, and Rational Plan Multi-Project. Okay, and that's the end of presentation. Thank you for paying attention.